Alright, I'm going to try to explain the common compensatory pattern in a way that makes it easy, or at least easier, in 3 minutes or less. But don't hold me to the 3 minutes, but I'll try. So I start at the bottom here and just commit to memory the lumbar lordosis and the respiration. Costal, increase. I don't think that's too hard. And then I pair the leg length with the arm length. Um, and it's like reaching up on a shelf, standing on your left foot. So if you imagine reaching up with your right hand, standing on your left foot, just start at the foot, and obviously you're not going to reach up, stand on your left foot, or reach up with your left hand. So reaching up, standing on your left foot, reaching up with your right hand, you'll be able to reach whatever you're going for on the shelf. And if you look at the picture over here, it matches that same thing. So your left leg that you're standing on is going to appear longer, and that your right arm is going to appear longer because that's the one that you're reaching with, aka your left arm will be shorter. So there's those two. And then there's only one exception here, but the rest of these can be explained by looking at these transition zone rotation differences and keeping in mind that they're going to move in type 1 mechanics, so it's rotated left, rotated and side bent in the opposite direction. So I always start at the top here. So this is indicative that, I believe it, the upper cervical or the AA or so vertebrae that you're going to be rotated left. So then you just remember that each of these transition zones are going to switch back and forth. And so the only exceptions up here at the T1 here. And this is how you explain it. So you go down to, so this would be the upper cervical slash AA area is going to be rotated left. And then you come back to here, down to here, and you're going to be at that transition zone between T1 and C7, and everything above that's going to be rotated right. So if you keep that in mind, which is not over here, but so this transition zone, you're going to be rotated right, side bent left. And then you come back down here to T12, and you look at that you're rotated left, which is going to result in side bent right, and that holds true for all of these vertebrae as well. And you can see that in the picture. Same way down here, look at T12 on L1, it's rotated right, going to resulting in side bent left. And obviously you can see this here, but we'll talk about it in a second. So the only exception is, and this was what took me a while, and then I finally just read it's just an exception, is that the infraclavicular parasternal area, the common compensatory pattern, is that the left is convex, indicating that it's rotated to the right. So that is more in line with our cervical here than the thoracic. And so and it makes a little sense when you come down to lower cervical. That's why they said lower cervicals, because there's still some residual right rotation from the cervical vertebrae in T1. So that's the only exception, that T1 is actually rotated to the right, which is going to result in a left convex infraclavicular parasternal area. So then you come down, so then keeping in mind that your lower and middle T regions are going to be rotated left, side bent right, that makes this one make sense. So looking at this one over here, you can see that these vertebrae are rotated to the left, and you know that your sternum is going to be lying over T1 to T7 or so, or T6, so you can just lay your sternum right on top of that middle of those joints, and you're going to see that your sternum has a left deviation. So that makes that one easy. And then once again, keeping in mind that arrow here, that's just going to make your lower thorax rotated to the left, just as you can see here this whole time. So then you come down to the pelvis, and I like doing the rotation first. So if you remember that, once again, left, right, left, right, in those 4 different transitional areas, you'll remember that the pelvic rotation is going to be rotated to the right. So with type 1 mechanics, what happens when you rotate to the right? So that's going to hold true for your entire lumbar section. Your pelvic rotation is going to hold true for that. With that in mind, what type of side bending do you have when you're rotated right? It's going to be side bending left, which is going to result in a higher left hip iliac crest. Sorry, your left iliac crest is going to be higher. So I'm not saying the mechanisms down here are exactly sound, but it's an easy way for me to remember it. Just remember the lumbar lordosis is increased and the respiration is costal. You pair the leg lengths and the arm lengths with reaching up off your left leg to grab something off a shelf with your right hand. That'll fit in there, making your left leg appear longer and your right arm appear longer, aka your left arm will be shorter. If you keep in mind these transitional zones and how this is rotated right at the sacrums, and that holds true for all the vertebrae up and on top of it, going up to the next level of transitional. That'll help you with everything except for this infraclavicular parasternal area, which is kind of an exception because it's got some residual left rotation or some residual right rotation from that cervical area. So that's going to make that, if it's rotated right, it's going to have a left convex, meaning it's more prominent on the left side in that area. Then you follow your T region that is rotated left, follows that your lower thorax is rotated to the left. So that's going to make the long axis of the sternum, because it's going to follow these. This rotation right here, it's going to make sense that it deviates left, come down to the lumbar region, and understand the pelvis is rotated right in regard to the lumbar, and that follows all the way up into the lumbar area. So that right rotation there is going to cause left side bending here. So just one way. Hopefully that helps a little bit to understand it.